Hi, everyone.
Hi everyone, who's ready for the last Luminary Talk for today? Awesome. So you've probably all seen by now that Snowflake is heavily invested in AI, and we're actively working to bring our own contributions and innovations into this space. So for the talk today, we'll be sharing how we did it and how you can apply some of our lessons and learnings into your own work. And specifically, we'll be talking about how and how much we use open infrastructure to develop open source AI models. And we'll then dive into one practical example of how we did this in Snowflake, which is pre-training the Arctic large language model. We'll describe how we've learned some of the lessons that we've learned as we were doing this, both at enterprise scale and doing it in the open. But first, let's talk about why it's important for AI to be open and why we can't simply apply some of our expectations about open source model to AI. So as you all probably know, working in the open affords many benefits, and many of these benefits are as true as open source AI as it is true for open source software. But that's not the entire story. Open source AI affords us the ability to kind of take a peek into our model, and it helps us better trust and understand the models that we use and the predictions that they generate. And leveraging open source AI in your workflows also means that you get to keep your infrastructures flexible and future proof, just as you would with open source software. And you also get the benefits of being on the shoulders of giants. So that means having many contributors from the community working on the same problems. So you get the benefits of a faster pace of innovations instead of having to build from scratch for your organizations. But open sourcing AI isn't the same as open sourcing software. To start, as language models get smarter, they also get larger and require specialized hardware to run. And so this raises the barrier to entry, not just in terms of contributing code, but even running the models itself. And this is a big reason why we've invested in making the Arctic API open and freely accessible for the first few weeks after the launch. And this is also why we funded a worldwide hackathon using these APIs. And you heard the announcement of some of these winners earlier in the afternoon at this stage. And so our goal here really is to maximize feedback from both the research community and you, the developers, at this early stage. So open sourcing AI is much more than just building on open standards and data sets. So as you can see in this slide, open source AI stack is around open data sets, open research insights that are not hidden behind a paywall, and also foundational ML libraries such as scikit-learn, XGBoost, PyTorch, and TensorFlow. And so there's a lot that goes into building this open AI stack, from open data sets, research insights, and so on. And so on this slide, you can see some of the data sets, papers, libraries that we use to develop Arctic. And we'll also share some of these resources with you at home at the end of the talk. So now I'm going to hand it over to Yusuf, who will share some of the details about how we built Arctic.
Thank you. Hi, everyone. As Doris mentioned, we have benefited quite a bit from the open source information that's out there while developing Arctic. So for the release, for the launch, when we announced Arctic, one thing that we really wanted to do was to make sure that we do it in a truly open manner. For that reason, we not only released Arctic with an Apache 2 license that is essentially giving ungated access to the waves to use in commercial applications as well, but we also committed to sharing insights and also data recipes around Arctic. So Arctic comes with data recipes around running inference on it and fine-tuning, and we have been sort of adding more and more code to our repo around this. And another thing is we have been sharing all the research insights that the team has developed along the way to the open source community as well. Just to give a sneak peek of this, we have been releasing a series of blog posts that we are calling cookbooks. And so far, we have 4 blogs that we have published. One of them is on Arctic's architecture and talking about mixture of experts and the decision-making process that went into the architecture choices that we made. Another one is on how the training system became much more efficient, going into the lower level optimizations that went into the process. Another one talks about the data insights that we have gained. And finally, there is the last one, which talks about instruction tuning with Arctic. And we have committed to sharing more blogs along the way. You can see the QR code to the URL that contains the cookbook. We'll be releasing more and more blogs along the same lines, sharing the insights. Just to give a short teaser to the one that talks about data, in general, one missing set of information that we have observed along the way is even though there has been many open source LLMs lately, the amount of conversation around where the data comes from and what work goes into how you process the data is diminishing more and more. So we wanted to make sure that we not only talk about the data recipes, but we also talk about the insights that went into how we process this data. So in general, pre-training involves going from large web dumps to high quality pre-training data sets. And the way you define high quality is dependent on a set of signals that your team basically has to define. These can be annotations that come with the web dumps, or it can be signals that you're defining on top of that. Then you need to filter out low quality segments of this data and then deduplicate across all your data sets to reach this high quality threshold. And that's exactly what the team has done. One thing that we used extensively during all this process was Streamlit. Here's actually an evaluation dashboard that the team has been using. This shows one ablation that the team has been running. We run many hundreds of ablations along the way. And the way this process works is you have your annotation signals and you apply a certain configuration of thresholds across all your annotation signals. And then you train a small scale model with this. And then you evaluate that small scale model based on a set of metrics. Then you can use dashboards like this to get a sense of whether those configurations actually improve on the quality of the training, and then define what high quality means in terms of the thresholds that you've been using. Finally, we have a public repo that contains these inference and fine-tuning recipes for Arctic as well. So it has dependencies on the Hugging Face Transformers library, of course, which is very common. For inference, we have been working on VLLM implementations of our own and have been working with the VLLM community and open sourcing these as well. Also, we have contributed to the DeepSpeed project with optimized kernels for running inference on Arctic. And again, all of these are available in the repo as well. Maybe the final thing to mention is you can build chatbots with Streamlit and the LLM of your choice. Here we are basically running Arctic in a chatbot environment, and you can actually use the Streamlit to build evaluation apps like this as well. So you can compare between two models and get the answers to the same question for the two models. We have run several evaluations like this to get a sense of where we are in terms of quality as well. Now I will hand it back to Doris to talk about how we actually optimize the data processing.
Thanks, Yusuf. So Yusuf just showed you some insights into how we build our open source LLM. And I'm now going to show you how we leverage open source projects such as Modin to scale our AI development even further. So if you're not familiar with Modin, Modin is an open source project, and you can think of Modin as a faster, more scalable version of Pandas. So Modin works like a drop-in replacement, which means that you just need to change one line of import statement in your code, and boom, all of a sudden you get faster performance on much larger data sets. And so you can continue to use your favorite familiar Pandas API, read CSV, group by, and using Modin, the runtime is much faster since the operations are running in parallel. And Modin is an actively maintained open source project based off of the research that we did at UC Berkeley on adapting database and distributed computing techniques to pandas. And the Modin open source project joined the Snowflake family last year to help scale enterprise data workloads through open standards. And so I'm going to show you a couple examples of how we're using Modin as part of Gen AI and LLM use cases. So we saw from Yusuf's demo how it's high quality annotation and data is important for pre-training LLMs. And so in this quick example, I'm running a signal annotation task with df.apply to about 300,000 documents. And so I'm gonna start this video. I have Modin running on the right and pandas running on the left as a reference. And you'll see how Modin completes much faster than pandas. So it's just completed now. It takes around 10 seconds or so. And pandas is still running right now. And so with Modin, the TLDR here is that you can instantly speed up your signal annotation and processing of large numbers of documents with Modin. And you can see here that the pandas just finished the completion of the runs. So the second thing I wanted to show is that Modin preserves the same pandas API. So most LLMs for code generation are able to generate decently good pandas code that can be dropped in for use with Modin directly. And so here's an example of this in action. I am asking Arctic here to generate some code for me to filter my data using pandas. And then I'm going to copy and paste this code, plop it into my notebook, and it just works. I run it, everything is great. And then now I ask Arctic to repeat the same by scaling up my code with Modin. And then the code stays exactly the same. It has one additional import statement. I plop it into the notebook, and it works. And I can now print out the data frame, and you can inspect the result of the filtered data frame. And then I have a second example here where I wanted to compute the fraction of the data set of the filtered and unfiltered data frame. Again, I plop it into Arctic, I ask the question, and then I'm going to put the code back into my notebook and run it. And the operation is exactly the same for Modin. So this is, again, one of the advantage of preserving the Pandas API, because we can leverage the training corpus and all the code generation that LLMs provide for Pandas code. And so as we build LLM infrastructure on top of Arctic, we need to make a large number of decisions around architecture, chunking, retrieval strategy, model parameters, and more. And we're recently joined by our friends at Truera, who have been developing an open source project called TruLens. And TruLens has given our AI research team a systematic way to track experiments as we're developing the AI stack. So this is an example of what the TruLens app leadership dashboard looks like. So for example, we can use the TruLens leaderboard to understand the performance of LLM applications. We can track application metadata, usage, and evaluation metrics. And because TruLens is open source, you can run your own evaluation metrics with any model on your own hardware. So it doesn't need to just happen with Arctic on Snowflake. And we also find it useful to look at individual records. So this is another example of this, where I can go in and take a look at individual records, identify when an application doesn't perform as expected by looking at each of the records. And so in this example, the record and the retrieve context is not very relevant, and it was identified by the TruLens feedback function. And so by clicking on the feedback function, we can look at the exact context chunks and the relevance of each, along with an explanation of why these chunks are not relevant to the user's query. So this is a very useful way of debugging, comparing the model outputs based on TruLens. TruLens also traces what our applications does, including steps like retrieval and summarization. And so with this knowledge, our AI research team can make informed iterations, such as improving our chunking or retrieval strategy, and get our apps ready for production. So wrapping up, today you've heard us talk about what we've learned in building and scaling our open source AI with Arctic, Modin, and TruLens. And AI is not the only place where open source is important for Snowflake. Many of the demos that you saw today and this week has been powered by Streamlit, an open source data app framework that we've been stewarding since 2022. And the Streamlit community has grown over 500% since becoming part of the Snowflake family. In addition, you've also heard us announce our intention to open source the Polaris Iceberg catalog in the next 90 days. And we're doing this because we believe that open data table standards, interoperability, and avoiding vendor lock-in are all important elements of the products that we built. And we're also proud supporters of key open source communities and foundations, some of which you'll see behind us at the Builders Hub today. In particular, NumFocus and PyTorch are here today as part of Dev Day, and so please stop by their booth and say hi to them on the Dev Day floor. So thank you again all for joining our talk today. Here's the QR codes to the Arctic Cookbook recipe, where we share research insights to efficient LLM training and inference for everyone. We've also open sourced the code that we showed as part of our demo today, so you can check out that other QR code to learn more. And with that, we'll end here. Thank you.